Alright, so section 4.3 is called standard form. We had just got done talking about slope-intercept form. It's basically the way an equation can look when you move the things around, when you move around the furniture a little bit. This is just another way a linear equation can look. And so it just goes like this: ax plus by equals c. There's our x variable, and there's our y variable. And this a, b, and c, those are all going to be the numbers. They're all going to be real numbers. And they're usually expected to be integers. More on that later, but I would think usually is maybe too weak of a word. Like, you should probably just consider that it's not true standard form unless these numbers are nice integers, not fractions or anything. And then for example, like this. So this is just a random example of an equation that is in standard form. And in other words, it just goes the x term, then the y term, then the equal sign, and then the regular number constant. So again, a, b, and c, they're all integers: -3, +5, +2. Again, it's just not in slope-intercept form. So like, this is opposed to slope-intercept form, where this is obviously not an equation that's solved for y. It goes like that, like I just said: x term, y term, equal sign, and then the number constant. And by the way, also speaking of slope-intercept form, unfortunately, these values of like -3, +5, and +2, they don't really mean diddly squat, compared to slope-intercept form, where the m and the b mean something important, for the line. These a, b, and c values don't really mean anything. But that's basically standard form. So if we needed to take this, what form is that in? Isn't this an example of something in slope-intercept form? Well, we want to write it in standard form. So once again, here's what we do first. This x term is on the wrong side. Like, we're going to move it over. We're going to subtract 3/4 x from both sides. Okay? That's not a good color to use. Let's get... Alright, and so now your -3/4 x is now going to be over here, along with the y, then the equal sign, then the number. So, it's getting there. We got the x term, then we got the y term, and then the equal sign. But what did I just say a couple minutes ago? This isn't really true standard form, because I can't really have my a value be a fraction. Whatever is in front of the x, and whatever's in front of the y, and whatever's over here on the right side, okay, those have got to be just nice integers. So how do I go about rewriting this where this is no longer a fraction? I'm going to multiply both sides by whatever's going to clear the fraction. So what do I multiply by to basically clear this denominator? Well, 4. Because when I now distribute the 4, when I multiply it to here, all that's going to happen is the 4's canceling, and I'll be left with -3x. But of course, remember, we also have to distribute the 4 to there, so we get 4y, and then of course, multiplying 4 to both sides, we get 8. So there we go. No integers with your a, b, and c values. But, okay, plot twist. Whereas you really shouldn't have fractions in your standard form numbers, you also pretty much shouldn't have your leading term be negative. Or at least, like, let's put it this way. You're taking the Keystone exam, and all the choices you have to choose from on some multiple choice question, your A, your B, your C, your D to choose from, guess what? If those answers are equations that are in standard form, you're not going to see a negative leading term. Okay, it's another sort of minor requirement for standard form. This first term really shouldn't be negative. So that's actually an easy fix. Think of it as we're multiplying both sides by -1, or we're dividing both sides by -1, which of course, if we do that, we're allowed to do that, multiply or divide both sides by -1. That'll make this a positive 3x, but of course it's going to change that to a -4y, and it's also going to change that to a -8. So I can't really say for sure which one is absolutely guaranteed to be, like your only good final answer. I would say this one is way more likely, especially on like a SAT exam or a Keystone exam for your multiple choice answers, because again, can't have fractions, but you also really need this leading coefficient, or at least of your x term, to be +3, not -3. So there's that example. Next, in this section, we're also going to talk about finding x and y intercepts. So the directions here say graph this equation using intercepts. Now, okay, let's take a step back here, take a breath, and let's remember something about the big picture. If you are supposed to graph this, we've already talked about methods to do that. Okay? If I just gave this to you yesterday or like before this lesson, you'd take this and go, hey, this isn't in slope-intercept form. This isn't solve for y. So I'm going to solve this for y. I'm going to get y by itself. And then on the other side, I'll be able to pick out my m and my b. And I can draw my line that way. And you're not wrong. So again, I'm not going to pretend we already didn't talk about another way, probably a better way, arguably, oftentimes, to graph this line. But we're going to do it using the intercepts. And it's not just the y-intercept, the x-intercept. So we're going to find both intercepts. If there's a y-intercept, there's also an x-intercept. So how are we going to find these intercepts? Well, I know, talking about or speaking of what I was just saying, the y-intercept, like if you solve this whole thing for y, the other side would be mx plus b. The b would be your y-intercept. But you know what? There's another way to find your y-intercept, okay? You can plug in 0 for x. And then when you solve for y, okay, that's going to be your y-intercept. So you have another way other than, hey, slope-intercept form and it's the b value. You could also do this, plug in 0 for x. Why is this going to work? Well, think about it. It's not that tough of a question, Why does plugging in 0 for x, flush out your y-intercept? Because think about anything on your y-axis. All these possible y-intercepts, isn't the x-coordinate always 0? If your y-intercept is -7, isn't that 0, -7? If your excuse me, if your y-intercept is 4, doesn't that mean 0, 4? And anything. So your x-coordinate is always 0 for y-intercepts. So anyway, this is what we do. This is a perfect thing. So 2 times 0 is 0. And then just like that, in about a second, this just becomes 3y. And then to finish solving for y, we can divide both sides by 3 and get y equals 4. There you go. And then just remember the context, like you're not just solving any random equation. You're solving this, so that you can figure out the y-intercept. So that's not just y equals 4, but it's a point. It's a separate point on my graph. So y equals 4 really means putting a dot right there, 0, 4. Now, how do we find the x-intercept? Well, think about it. If plugging in 0 for x flushed out the y-intercept, wouldn't plugging in 0 for y do the same thing? Yeah, because think about all these possible x-intercepts. If your x-intercept was -6, doesn't that mean -6, 0? If your x-intercept was 3, wouldn't that really mean like 3, 0? The y value is always 0 for x-intercepts. This is perfect. So it's a very straightforward strategy, is it not? And 3 times 0 is 0. And then, of course, that's just going to be 2x. Yeah, just goes away nicely. And then to finish solving for x, what? You have to divide both sides by 2. And you get x equals 6. But again, remember, what's the whole context of solving for x and getting x equals 6? That it's the x-intercept, which is its own separate point of 6, 0. And guess what? If you have two separate points, can't you now connect them to make your line? There you go. So that's the process of graphing an equation using both intercepts. It's like an alternative way. Now look, final little comment before moving on here. If this equation was already in slope-intercept form, you're probably just going to go with that approach. But this was standard form, is it not? This is standard form. This is why this whole example problem type is in this section, because this was given to you in standard form. And you know what? When what you're given is standard form, this is not a bad strategy at all. This might be the preferred, better strategy when what you're given is standard form. Because again, if you were given slope-intercept form, you would know your y-intercept the instant you looked at it, because it's the b in mx plus b. So anyway, that's the final comment. Standard form, man, this might be the better strategy to graph your line. Just plug it in 0, boom, bam, plot both intercepts, connect them. All right, last little phase of this lesson is about horizontal and vertical lines. I'm pretty sure in this chapter you've already been introduced or reminded what the slopes are of horizontal and vertical lines, because all horizontal lines share the same slope and all vertical lines share the same slope. This right here is about what do the equations look like. What do the equations look like? Do they look like y equals mx plus b? Do they look like standard? Maybe. Okay, so here we go. Let's take a look. Let's graph x equals 2. Well, you might be looking at this and your immediate reaction is, where's the y variable? Just like over here, let's graph y equals -3. You might be thinking, where's the x variable? This one only has x, and this one only has y. Well, guess what? These are what they're going to look like when they're either horizontal or vertical. Let me explain. X equals 2. That equation in its entirety pretty much means like, well, let's take a look at it from a solution approach. Could you give me an ordered pair that is a solution to x equals 2? Not just a number for x, but an ordered pair, x and a y. And I know you're thinking, well, there is no y. Well, then wouldn't 2 comma 0 or 2 comma 3 or 2 comma negative 1 or 2 comma anything? Doesn't matter what your y value is. As long as x equals 2, it's going to be a solution to this. So imagine graphing not just these 3 points, but the infinite number of other ones. 2 comma 5, 2 comma negative 1. Well, sorry, that was a repeat. 2 comma negative 4, 2 comma 6. This is going to be a vertical line at x equals 2 because of all these solutions. Okay? Likewise, over here, graphing y equals negative 3, a few solutions that would work would be, well, 0 comma negative 3. You see how y equals negative 3? Or 4 comma negative 3? Or negative 5 comma negative 3? Or anything as long as the y-coordinate is negative 3, it would technically solve that, So if you plotted all these points, 0 comma negative 3 is right there. 4 comma negative 3 is right there. So we have 0 comma negative 3 and 4 comma negative 3. And this is, so, and if you kept plotting dots like 6 comma negative 3, 1 comma negative 3, it pretty much just makes a horizontal line at y equals negative 3. So you would just go to y equals negative 3 and draw a horizontal line. Just like over here, you would just go to x equals 2 and draw a vertical line. Now, here we go. Check this out. Now, this one, you can just, go with the solutions approach or whatever. But fun fact, technically, this equation does fit the mold of y equals mx plus b. You can make this fit the y equals mx plus b like form. It would just be 0x, would it not? Like, isn't this basically y equals 0x minus 3 because 0x is like nothing, Yeah, so doesn't this make sense how you could just say, oh, my b value, my y-intercept is negative 3 right here, and then your slope right here, your m, is 0, which means like up 0 over 1 or up 0 over whatever. Now, so there you go. This is always going to be a horizontal line when there's only a y, but it does technically fit y equals mx plus b, whereas this is super weird. Like this doesn't, you can't make this fit y equals mx plus b. So 2 more quick examples, and look, there's actually a very nice memory trick if you can remember. Like, I guess it depends on how well you, or how much, or how memorable you think, or easy to remember J.Falk is. So as long as you can remember J.Falk, that's most of the battle, because this summarizes what to do with horizontal and vertical lines. Okay? So the J over here. So the H stands for horizontal, right? The V stands for vertical. And the Y right here, this Y represents that the equation is only going to have a Y variable. So every time there's only a Y, J.Falk, H-O-Y, it's going to be horizontal. So this one's horizontal. So all you got to do is go to y equals 1, and draw your horizontal line. Just likewise, or conversely, Vux, V-U-X, if your equation only has x, like this one, then it's a vertical line. And all you got to do is go to x equals negative 4 right there and draw your vertical line. That's it. That is it. And the other thing, but J.Falk is even more than that. this right here, which is actually not an O technically, it's a 0. So this right here represents the slope of a horizontal line. And this right here, the U, represents the slope of a vertical line, which this U stands for what? It stands for undefined. So there you go. That's J.Falk. It's amazing. So horizontal lines have a slope of 0, all of them, and they all just have an equation that only has a y variable. And then vertical lines, they all have undefined slope, and the equations of vertical lines only have an x variable. And that's that for section, 4.3. Thank you for following along.